Hello and welcome to Talk Frankly Show. My name is Nagy and I'm happy to be with you tonight. Like every night, we are going to talk frankly. Like every night, we are going to ask the questions we all want to know the answers to. As you remember, recently we had the Russian President Vladimir Putin here, and we directly asked him about the state of democracy in Russia, or the German Chancellor Angela Merkel, whom we directly asked, Angela, warum haben Sie keine Kinder? Angela, why don't you have children? Soon there will be the former US President Donald Trump and the current French one Emmanuel Macron here as our guests. But not together, of course, because they could turn it into a love game, and in our audience we often have small kids. Like every night, we are going to talk frankly. And like every night, we are going to have a very special guest. But tonight's show is a very important one for another reason. In exactly 3 months, there will be the presidential elections. In this regard, later in the show, I'll make a very surprising and very important revelation. So stay tuned. The upcoming presidential elections are very important because today, at this moment, the Earth is suffering. Either we take some measures or we are going to destroy the planet and the humanity is over. Tuvalu. Have you ever heard anything about the state of Tuvalu? Well, me personally, I haven't heard anything about Tuvalu, but soon enough it won't matter anymore because Tuvalu is going to disappear very soon. After all, Tuvalu is an island country and the highest peak of Tuvalu is about 5 meters above the sea level. Well, historically, it's not going to be the first country to disappear under the ocean. Atlantis did it, but it was a while ago. According to the Millennium Project, the annual State of the Future report, the biggest problem we are facing today on Earth is the lack of access to safe water. Do you know that 1 in each 9 people around the world don't have access to safe water? Well, however, thanks to globalization, they certainly have access to Starbucks and Coca-Cola. Another big problem, according to the same State of the Future report, is the ever-increasing gap between the rich and the poor. And this, of course, is very good news for the rich and very bad for the rest 99% of the world population. 2 other big issues are the lack of proper education and democratization. And those 2 questions are related because in order to function properly, a democratic society needs people able to perform independent critical thinking. However, the current educational system doesn't provide people able to perform independent critical thinking. Actually, our current educational system doesn't produce people able to perform any kind of critical thinking, or even thinking, or even something that looks like thinking. What it provides today are workers for factories, soldiers, terrorists, and a few university professors. And those 2 last for some people are the very same thing, for Mr. Erdogan, for example. But soon enough, even armies and factories won't need people anymore. The artificial intelligence is going to replace us. But there is no place for worries. Starbucks and Coca-Cola will still be hiring people. Speaking about the artificial intelligence, many people are afraid of it. But as the President Putin said while he was here, the artificial intelligence is the future. Whoever becomes leader in this sphere will be the future ruler of the world. In this regard, Putin expressed his worries of China. But there is nothing to worry about Chinese. The only thing we have to do is to start learning Chinese. Ni hao. Jajan, Shushe, Wakacha, Walking Butong, Chishe Shema. Well, those were the 6 phrases enough to survive in China. There is no place for worries. It took me 10 minutes to learn them. As long as I can, everybody can. And the last big problem we are facing today on Earth is still the biggest source of energy is burning fossil fuels. And this, of course, the biggest reason for the global warming. But this is a reason for another big problem, the acidification of the oceans. Yes, because the CO2 from the atmosphere mixes with carbonic water and mixes with ocean water and becomes carbonic acid. You might ask, who cares? Who really cares? Plankton cares. Carbonic acid kills plankton, and plankton is the basis of our food chain. No plankton, no fish. No fish, no parties. Only fake sushi with cucumbers. But also the plankton produces more than 50% of the oxygen we breathe. Here I see some people smile and say, come on, we all know that breathing is dangerous, especially in winter in Sofia. Well, there is no two opinions. All those questions are very important. Either we take measures and we resolve them, or the human race is over. In order to talk frankly about all those issues, we invited a very special guest. Our tonight's guest is a scientist. He is a professor. He is an astrophysicist. But most importantly, he is the leading candidate for the upcoming presidential elections. And speaking about astrophysics, do you know which is the only planet in our solar system that is married? Saturn! You can guess from its rings. Ladies and gentlemen, please welcome Professor Dr. John L. Ivanov! Hello, Professor.
Hi, buongiorno.
Hello, thank you for accepting our invitation.
My pleasure.
Finally, finally someone would be able to answer a question I had since I was a kid. Why is that Jupiter pants are never falling down?
That's very easy. It's because Jupiter has an asteroid belt to keep his pants up. But one minor correction, if you allow me. Saturn is not the only planet with rings. Uranus and Neptune also have rings, and so does the Earth.
The Earth?
Yes, the Earth, but our ring is made of space junk.
Oh, I see. You mean empty plastic bottles, used plastic bags flying around the Earth in orbit. Right?
No. I mean pieces of old dysfunctional satellites.
Oh, okay. I see.
Yeah.
Well, Professor, get some coffee.
No, I shouldn't drink coffee. Coffee makes me react strange. I'll pass.
Come on, be a man. Drink some.
No, thank you. No.
We buy only the best coffee in the world. Try it.
The best one.
Well, Professor, are you ready to talk frankly?
Yes.
Are you ready to answer all my questions? You know, in our show, we ask all kind of direct and very often unpleasant questions.
Yes, I'm ready.
May I call you Johnny? Question number 1.
Yes, and may I call you Danish?
Of course. This is the name my parents gave me. Johnny, this is not the first time you're our guest, right? You were here about 2 years ago.
Yes. How could I forget that? Yes.
Yeah, you just got married with a lovely woman back then. How is she doing nowadays?
Oh, she's fine. We just got divorced.
Oh, really?
Yeah, she ran away with a particle physicist.
We see that Professor Ivanov hasn't lost his sense of humor.
No, that's actually true. She really ran away.
Well, I'm sorry to hear that then.
That's okay. I guess that being a particle physicist, he had more energy than I did.
Well, Professor, let's get straight to the point. Many of our audience member tonight know about you, but for those of them who haven't heard much about you, we prepared a short video presentation. Please, let's have the video biography of Professor Ivanov.
Thank you.
Dr. John Ivanov is a world-renowned professor of astrobiology. He is the last descendant of a famous 18th century aristocrat from Bohemia, present-day Czech Republic. The mother of John, Reina, was a famous fortune teller. She studied astrology and believed that the planets have a subtle yet very powerful influence over the life of every human being. In her 20s, Reina fell in love with a Bulgarian gypsy musician, Roman Ivanov, and fled to Bulgaria, where John Ivanov was born. His mother taught him to love the stars, his father to treasure art and music. As a scientist, Professor Ivanov works on the search for exoplanets, distant worlds in space that we humans may one day call our second home. 2 months ago, Professor Ivanov announced his candidacy for the coming presidential elections. He stated, "Coming from science, I plan to use the scientific method to deliver policy based on science." Will a scientist really make the difference to our world that we so sorely need? We are about to see.
Johnny, why is your middle name L and not R by your father's name, Roman?
I just prefer to use my mother family name, Łapkowicz, an old aristocratic family name from Bohemia.
And did you recognize the music? We managed to discover a rare recording with your father's violin.
My father used to play his violin, but he never played with me.
Well, enough of drama. Let's get really straight to the point. Why should we vote for you?
Let's first start with a big thanks to the audience, to all those people who have decided to trust me.
Wait, they haven't voted for you yet.
They will.
You see. 2 months ago, when you announced your candidacy to become a president, many people were skeptical, including me. By the way, I'm still quite skeptical, but indeed, according to some polls, you're the leading candidate of these elections. Why is that? Why are you so popular with some people?
I'm the leading candidate, according to all polls. Why is that so? Well, today we are facing big problems here on Earth, and you mentioned some of them in the beginning, Danish, in the beginning of your show, and traditional politicians just seem incapable of solving them. They get their decisions based on their guts, on their instincts, on their intuition, or maybe, just maybe, their decisions are motivated by money from banks, money from industry, or money from close friends. If we want to change that, we need to make political decisions based on critical thinking and hard data. That's why we need to use the scientific methods to make the political decisions. That's why we need a scientist for a president, and that's why you should vote for me.
You mean I should vote for you?
Yes, you too.
I have a better option to vote for on these elections. But we are going to get to this later in our show.
Okay, that's what democracy is all about. But I can provide answers to many of the problems you mentioned in the beginning.
You mean how to save the Earth?
Yes, but not only that. The Earth is important, but it has an expiry date. That's why we need to search for another home for us humans, a home in space. And to do that, we need to dramatically increase the funding for space research right now.
Speaking about space research, do you allow me to present to our audience tonight your new book?
Oh, thank you. Thank you.
Professor Ivanov just got published a new book.
Yeah.
It's a small book with a big title, The Long Way to the Stars.
Come on, it's not a small book.
Come on, it's small.
It's not small, and besides, size doesn't matter.
Size does matter, ask Donald Trump.
It's not a small book. The font is very small and there are almost no illustrations.
Let's not talk how small the font is and how small the number of pictures inside. Let's talk about the content. Is this book related to your candidacy to become a president?
But of course it is. You see, Danish, when you have something important to say, you should write it down, just like I did in my book, In the Long Way to the Stars. I show why our past as humankind, we are connected to space. That's why our future is also in space. And right now we are facing a big problem. Our Earth has an expiry date. A giant asteroid may destroy the life on Earth. That's why we need a second home. We need a new planet for us. We should do this now. We should grasp this opportunity as soon as possible.
Whoa! Are you a preacher or something? You sound like some kind of guru of new religion.
No, this is the voice of science, of pure science.
Could you please get back to Earth and sit down in your chair, please? Even if I may not agree with many of the ideas inside your book, I don't agree with most of them. I still find it interesting. I read it. It's a very quick to read.
Oh, it is sweet and to the point, the way I like it.
Now I see why his wife left him for a particle physicist.
Very funny.
Could you please tell us a little bit about the ideas inside? Please, the stage is yours. What is inside this small book?
I'd love to present my ideas. Thank you for this opportunity. But please, can you show again the book to our audience, please? Please see, dear guests at the ToWFestival. It's not a small book. It's 15 centimeters. That's not small. In The Long Way to the Stars, in my book, I focus on some of the most important questions that any one of us has asked even since we were kids. And you too, Danish, you too were a kid. Maybe a mean one, right?
Oh, you start judging.
No.
In any case, my father used to play with me when I was a kid.
I'm not judging. I'm just saying that in The Long Way to the Stars, I'm focusing on one of the most important questions. It sounds simple. Can we find a second home for us, humans in space? Yes, we can. In The Long Way to the Stars, I show why the study of life on Earth is part of the study of the universe. I show the main ingredients, the conditions that are on Earth and that allowed for life on Earth to emerge and to develop. Then I focus on the search for new planets out there, new places in space we can one day call our second home, a home between the stars, Danish. Out there in space, dear guest, I assure you, there are thousands of new worlds, new planets that are the exact twins of the Earth. We just need to find them. And to find them, we just need to increase the funding for space research. But the most important thing is that we should do this right now. Right now, we need a plan B because our Earth has an expiry date. An extinction level event like a giant asteroid is surely coming, and it will happen. Well, it won't happen tonight. It won't happen today or next week, but in the next hundreds of years, it's a certainty. That's why, Danish, I believe that the problems you mentioned in the beginning, the problems with the sustainable development, we can only solve them if we change the way we think, if we change the way we fund fundamental science and innovation. We need to dramatically increase the funding for space research. Our aim should be one, to colonize space as soon as possible in order to survive.
This appears quite appealing, but how can we be sure that this is true? And most importantly, that this is the right choice to vote for on these elections?
I got your question, but I want to start from the beginning. I want to show that our past as humankind is connected to space, and so our future is also in space. And tonight for the ToWFestival, for you, dear guest, I have a game I want to play with you, but I need your help. I need your help, Danish, and the help of the audience. Would you help me? Yes,
Well,
I hope so. So please, please. I will take you back in time. I'll take you on a journey back in time to the first moments when our solar system was born 4.5 billion years ago. So to do that, I ask you to close your eyes. Please, Danish, please, dear guests, close your eyes. And let's imagine together the birth of the solar system. Imagine how a big cloud of gas and dust is dancing in space. It dances to the rhythm of gravity. Gravity is the force responsible for us to be safely on the ground, but gravity is also the force responsible for the formation of all stars and all planets in the vast universe. Now keep your eyes closed and imagine how two tiny pieces of dust start to dance and get slower one towards the other. They attract each other like two people in love. And the closer they get, the faster their dance becomes. And when they combine together, these dusty particles, they stay together forever. And they start to attract more matter. Thus, slowly but surely, the center of the cloud gets contracted, the temperature rises, and the magic trick happens. Nuclear fusion starts. Hydrogen atoms combine together to form helium atoms and release light. Open your eyes now and to witness the birth of the solar system. This is how all stars in the vast universe are being born. And to emphasize the role of gravity even stronger, let's play another game tonight. Danish, please, dear guests, you two, please stretch your right arm in front of you. Please, Danish, stretch your right arm. Yes, and make a strong fist. Yeah, so that I can see it.
do you
Yeah.
want a box?
No, I'm not boxing you. No, I'm just asking you to make a fist. And please answer my question. Is it getting hotter inside your fist? Is it getting warmer? Yes, it is. This is the same thing that happens in space. The gravitational field is contracting the gas, it gets heated, and the nuclear fusion could start. So the next time you make a fist, think of tonight. This is how stars are being born at this very moment, but this is not the whole story. Make a fist, please, Danish, dear guest. Make a fist with your other arm. This is how you may form a binary star
You really
system.
want to fight?
Maybe later. But this is how you can form a binary star system, a system with two stars living together. And if the material is not enough to form a second sun, then planets are being formed. First, we have the gas giants, planets made of gas, just like Jupiter and Saturn in our solar system. And after we have gas giants, then from the rest of the materials, the gravitational field is making the rocky planets, the planets that we see in our solar system too. These are the first four planets: Mercury, Venus, the Earth, and Mars. So let's relax our hands and say again the names of the first four planets. It's Mercury,
Mercury, Venus, the Earth, Mars.
Mars, yes, applause, yes, the first four planets. And this is our home, the solar system. Isn't it beautiful?
Is it
It
the
is.
solar system?
Of course it is. Do you like it? Yeah.
I imagine it's somehow different,
How come?
with some more space between the planets.
But of course it's not to scale. We have to use our imagination. We have to use our little gray cells. But even though the distances here are not real, all the pictures of all planets and of the moon are absolutely real. They're taken with our space telescopes. That's why space science is important. By studying space, we learn more about our home, the solar system. And if we invest even more in space research, we will know how many of those planets that are twins of ours are out there in space. The answer is very clear even today. We have many of them.
Well, this appears interesting, but I cannot get the link between the need to colonize the space with that to survive as humans to survive as a biological species.
I'll come back to this a little bit later. I want to start from the beginning. I want to show that our history is connected to space, so our future is also in space. Let me show you what I mean. Speaking of the past, let's go back to the formation of the Earth. 4.5 billion years ago, shortly after the Earth was formed, something extraordinary happened. A planet, maybe with the size of Mars, hit the Earth and formed the Moon. Think of that, Danish. Think of that, dear guests, the next time you are walking under the moonlight with your loved ones. The Moon was once part of the Earth. That's why when we study space, we learn more about
Excuse me, is it the moment when the dinosaurs went extinct?
No. Since there are no stupid questions, just stupid answers, I'll answer your question. This is the formation of the Moon 4.5 billion years ago, and the death of the dinosaurs by a strike with a giant asteroid was 65.5 million years ago. So these two events are not connected. But shortly after the Moon was formed, something extraordinary happened again. Asteroids and comets from the outer parts of the solar system started to rain down on our planet. They rained down on the Earth. And with these asteroids, with these comets, water came to our planet. The water that we now see, the water flowing on the surface of the Earth, the water in our bodies, the most part of it came from space. Think of that, Danish. Think of that, dear guest, the next time, tomorrow, when you're having your morning cup of coffee or your morning cup of tea. We are really made of space stuff.
You want to tell us that water came on Earth from space in plastic bottles? Really?
No, water didn't come on Earth in plastic bottles, nor did it come in glasses. Water is important for another reason. It is the most important ingredient for life as we know it. And out there in space, Danish, out there in space, dear guests, there are thousands of planets with liquid water on the surface. We just need to find them. How can we find them? With the help of the best space telescopes, like the Kepler Space Telescope. Here it is. The Kepler Space Telescope is searching for exoplanets. An exoplanet is a planet that orbits around a star other than the Sun. So, in simple words, exoplanets are all those words that we hear that are being discovered in deep space. New planets in space. Kepler has already discovered more than 2,000 new planets, and today we have a bright, brand new telescope, a new planet hunter. This is the TESS Space Telescope. TESS was launched by NASA just 2 years ago, and in the next couple of months, TESS expects to find more than 20,000 new exoplanets. Imagine that, Danish. This is 10 times more than Kepler did. 20,000 new worlds for us humans. And if we invest more in space, we will know how
Excuse
many of
me,
these
can
planets
you
are
make
twinkable.
pictures with those cameras?
But of course we can take pictures. You see, we have 4 cameras. 1, 2,
And can
3,
we make
4.
videos with them?
We can make videos too, but Danish, the most important question is, how can we tell that on those data is a planet or not? How can we tell and distinguish between a false discovery and a true discovery? The only way to do that, the only way to distinguish between true and false is by using the scientific method. This is why science works. And this is why we need to apply the scientific method for making the political decisions. But tonight, I want to show you how we can use the scientific method to discover new worlds in space. One of the best methods to discover a new planet is the transit method. The transit method is something very easy to remember, very easy to understand. Imagine that this is the star and here is the planet. The gravity of the star makes the planet to orbit around it. And when the planet goes in front of the star, this is called a transit. So during a transit, the planet goes in front of the star and it blocks part of the star's light. This means that the astronomers on Earth see how the light of the star diminishes. See how this looks like scientifically. Let me show you a graphic. On the left side, you see that the planet is not in front of the star, so you see the full light of the star, like it's shown in the graphic. But when the transit begins, you see how the measured light goes down. And when the transit ends, you see how the light curves goes back to normal. If these changes are happening periodically, this means that around the star there is an exoplanet. Let me show you a video in action. You see? Now the transit begins, and you see how the light drops down, and when the transit ends, the light goes up, and this is happening periodically. See a transit and a change in the light curve, and this goes on and on and on, but this is not the whole story. During a transit, the planet goes in front of the star, and the bigger the planet is, the bigger the change in the brightness becomes. This means that by using the transit method, we can not only tell that there is an exoplanet, but we can tell the size of the exoplanet. Furthermore, when the planet goes in front of the star, the light of the star passes through the atmosphere of the exoplanet and gets absorbed by the chemical elements in it. When the scientists, the astronomer, receive the signal, they can tell what is the atmospheric composition of the exoplanet. Imagine that, Danish. Imagine that, dear guests. We can sit here in our homes and we can know what the air is on a distant planet out there in space. It's magical, right? If it's the same air, like the air here on Earth, this means that on this exoplanet, there may be all the other conditions for life, like liquid water on the surface. That's why we need to invest even more in space research to find those exoplanets, to study their atmospheres, and maybe find a way how to get to them. This is the most...
You're speaking all the time about giving more money, spending more money on space research. Don't we possess other methods that are also efficient to discover other planets and that are not so expensive, so to say?
You're asking about other methods, right?
Other cheaper methods.
There are other methods, but they are not cheaper. Actually, the second most used method for finding exoplanets is the so-called radial velocity method. Radial velocity method may sound strange, but it's something very easy to understand too. So let's start with something similar. I suppose that you, Danish, and that every one of the audience, well, any one of us has heard how the sound of an ambulance is changing when the ambulance goes towards us and when it moves down the street, right?
Doppler's effect.
Oh, you remember some of high school physics, Danish?
I do.
Good for you. Yeah, absolutely right. This is the Doppler effect. The Doppler effect is the change of the measured frequency of a sound wave emitted from a source that's moving towards or moving away from the observer. How can we remember the Doppler effect? Let's play another game here tonight. Let's play that right now we are at a Formula 1 race. We love fast cars, so we are at a Formula 1 race. We are sitting and we are observing how the cars go in front of us. We see the cars, but what do we hear? We hear...
We have a real ninja in our show tonight. Could you please make it again for our audience?
Oh, just for you, Danish. Just for you. The Doppler effect, the change in the frequency of a sound wave emitted from a source that's moving towards or moving away from the observer. And the same thing happens in space. But of course, in space, we don't have sound waves because there is no medium that the sound waves can propagate through. Instead, what's changing is the frequency of the light of the objects in space. And what type of objects do we have in space, Danish?
Stars.
Yeah, stars. We have stars. Absolutely right. So now let me show you how the radial velocity method, also known as the Doppler method for finding exoplanets, actually work. Imagine that this is the star and this is the exoplanet. The gravity of the star makes the planet to orbit around it, but the gravity of the planet is also swinging the star forward and backward towards us.
Swinging forward and backward. Is it somehow related to particle physics?
No, that's not related to particle physics. It's gravity. You see, the gravity of the planet is moving the star. It's swinging the star forward and backward. And when the star is going towards us, its light is changed to the blue part of the spectrum. When it goes away, it's changed to the red part of the spectrum. If we have a periodic change in the measured light, blue shift, red shift, blue shift, red shift, then this means that around the star there is an exoplanet. And this is very important. Let me show you a video of this method in action. Let me show you a video. So here in the center, You can see the star, and now you can see how the star gets closer to us, and now you see how the spectrum gets moved to the blue part, and then the star goes away, and you see how it gets moved to the red part, and this is happening periodically. Let's say that this star is the sun. Our sun is a yellow dwarf star. It's shining with a yellow color. If the sun goes towards us, it will be a little bit bluish yellow. If it goes away from us, it will be a little bit reddish yellow. If we have a periodic shift, blue shift, red shift, blue shift, red shift, then around the sun there is at least one planet. And by using this method, the radial velocity method, the Doppler method, scientists have found the first exoplanet around the star similar to the sun. This is the exoplanet named 51 Pegasi b. 51 Pegasi b was discovered by two scientists, Michel Mayor and Didier Queloz, in December 1995. It is a new type of exoplanet, a planet we've never seen before. It was discovered in December, so a new exoplanet. Who could have wished for a better present for Christmas?
Is this what you offered to your ex-wife for Christmas?
No.
I really see now why she left you.
Danish, see, science is making the best presents for everyone. Of course, one scientist or a group of scientists may have been the actual discoverers. But once we have a discovery, it belongs to humankind. That's why science is important. That's why we should fund science. But now let me show you what's the most important bit about 51 Pegasi b. This is a planet like we have never seen before. It's a big gas giant, bigger than Jupiter is. That's why it's a prototype of a new class of exoplanets called hot Jupiters. 51 Pegasi b is very close to its star. It's so close that it makes one orbit for just 4 days. Compare that with the 365 days it takes the Earth to orbit the Sun. So what do we have here? A new type of planet, a big gas giant, very close to its star with a very short ear, a planet we have never seen before.
Excuse me, but it doesn't seem to me like a home sweet home for humanity. We can't live on a planet made out of gas, of hot gas, where the year lasts but 4 days.
But not all exoplanets are so different than ours. Actually, to find the second Earth out there in space, we need to search for exoplanets in a very special zone, at a place called the habitable zone. The habitable zone is just the name of the range of orbits, the range of distances around the star within which a planetary surface can allow for liquid water to be on the surface. Take, for example, the Earth. You can see on the graphic right up there, the Earth is right in the center of the habitable zone of our star, the Sun. And that's very good news for us, Danish, because if the Earth was at the center of the closest planet to the Sun, what's the name of the closest planet to the Sun, Danish?
Mercury. Freddie Mercury.
You're absolutely right. If the Earth was at the place of Mercury, all the water would evaporate immediately. And if the Earth was at the place of Mars, all the water would freeze down immediately. But good for us, the Earth is right in the middle of the habitable zone of the Sun. And out there, dear guests, out there, Danish, there are thousands of planets in the habitable zones of their stars. We just need to find them. Let me show you my favorite exoplanet in the habitable zone of its star. It is Kepler 186f.
Uh-oh. Wasn't she your ex-wife?
I don't know how this light came up here. Can we change the slide, please? Yes, Kepler, 186f.
Why does it look like a golf ball?
Sorry?
Why is it white?
Why it's white?
Do you have snow on it?
It's white because we don't know nothing about the atmosphere or about the surface of this exoplanet. That's why it's blank. But this is about to change. When we launch the next space telescopes, like the James Webb Space Telescope, hopefully by the end of this year, we will discover the secrets of the atmospheres of this and many other exoplanets. And If we invest even more in space research, we can understand on which of those exoplanets we may actually step on and we may survive on. And now, Danesh, now let me tell you what's the relation, the link between the search for exoplanets and the survival of humankind. Right now, scientists from different disciplines, astronomy, biology, geology, chemistry, physics, they're combining their disciplines into one brand new science called astrobiology.
Wait, weren't you an astrophysicist?
Yes, I am, but astrobiology is a new science that studies the emergence of life in the universe. And out there in the universe, Danish, out there in space, dear guest, we have all the ingredients for life as we know it. We have the right type of planets around, the right type of stars at the right places. We also have all the necessary building blocks of life, like the necessary amino acids, for example. Furthermore, today we have a brand new scientific hypothesis that explains how life, once emerged, can lead to its self-destruction. Let me tell you about that. Let me tell you about the entropy hypothesis. Entropy. Entropy is a term coming from thermodynamics. Thermodynamics is the science of heat. So whenever you, Danish, whenever you open your fridge, or whenever you, dear guests, whenever you put your air conditioning on in your cars, this is some thermodynamics at action. Entropy, on the other hand, entropy is just a measure of the number of micro-configurations that a system may have. So you may think of entropy as a measure of disorder, as a measure of chaos in a system. The second law of thermodynamics states that in a closed system like the universe, entropy may only increase with time. What does this tell us in our everyday lives?
What?
Let me show you. Imagine that I have a glass here in my hand. If I drop it down, it will crash into pieces, right?
Mm-hmm.
Yeah, I actually have a picture of it. See, I've taken a picture of a broken glass. Yeah, here it is. We all know that glasses do break down, but has any one of us ever seen how a broken glass spontaneously become whole again? No!
Yes!
How come?
At home, when I turn on the video and when I push the button rewind, the glass becomes whole again.
But this is real life, Danish, not just some video.
Well, you ask if anyone ever saw a broken glass getting back together, and I just say that I saw.
Okay, besides your video, in real life, glasses do break down, but don't come back spontaneously to become whole again. Why? The reason is entropy. Please take a look at the right picture, the picture with a broken glass. This state is the state with maximum chaos, maximum disorder. This is the state with maximum entropy. It doesn't require energy to be stable. It is sustainable. But on the other hand, if we want to make the glass whole again, we need to input some energy to decrease the disorder, to decrease the entropy. Since the second law of thermodynamics states that entropy may only increase with time, glasses do break down, but don't come back together spontaneously. The entropy hypothesis states that maybe this law applies to biological evolution, to the evolution of organisms. Maybe, in the evolution of organisms, the organisms that survive are the ones that consume more efficiently the available free energy. This means that the organisms that survive in evolution are the ones that increase entropy at a more efficient rate. These organisms survive and invent new ways of even faster, of even more efficient way to increase the entropy. And this goes on and on until the total consumption of the whole environment. What does this tell us about our society?
What does this tell us?
Let me show you. See, we are efficient consumers, aren't we?
Eureka!
Yes, we are very efficient, and maybe the reason for this is that this is just the application of the second law of thermodynamics applied to biological evolution. If this is true, this means that things won't get better by themselves. We should act now, otherwise we are prone to self-destruction.
Professor.
That's why we need a plan B, and this plan B should not
Professor.
be backward. We should look into space. We should find
Professor,
other planets
stop.
for us. This is what the long way to the sun
Professor,
is all
stop!
about.
Commercial break! Talk Frankly show. I'm Denis Nagy, and our special tonight's guest is Professor Dr. John L. Ivanov, a world-renowned astrophysicist and the leading candidate for the upcoming presidential elections.
Thank you. Thank you.
Johnny, you mentioned several times that we should increase dramatically the funding for space research.
Yes.
However, we already spent so much money here on Earth for weapons, and now you want to even throw more money for space research. Why don't we, for example, with this money, why don't we resolve any of the problems we are facing today on Earth? Why don't we, for example, bring some water to people who don't have access to safe water with it?
Well, I'm not saying forget about the Earth and just do space research. No, I'm just saying that if we want to improve our lives, if we want to improve the situation we live in, we need to drastically improve our future perspectives.
I didn't again get anything of what you just said. You sound like a real politician. I ask you a concrete question and you answer with some blah blah. What concretely you mean?
Concretely, I mean technology. Technology can make our lives better. Take, for example, the computers. The first computers were bigger than your television studio, but right now we have computers in our pockets. They're in our smartphones.
I agree that historically it was very important to develop technologies. However, today we already possess technologies with which we are able to transform the Earth into a real paradise. What do we do instead?
If we don't invest in space, we would miss the next technological revolution. What's even worse, we won't have a plan B for our survival.
Why do we need a plan B when we have a plan A here on Earth and it has been working properly for millions and millions of years?
Yes, we have plan A, but we can make it better. Take the economic system, for example. Right now, we are using a lot of resources like platinum group metals. We use platinum group metals in autocatalysts or in electronic devices, but out there in space, in the asteroid belt, remember, the one that keeps Jupiter pants up, well, there are iron asteroids out there. We can go there, harvest the metals, deliver them back to the Earth, and this will drive down the price of technology so that many more people could afford it.
Wait. Are you proposing to divert an asteroid towards the Earth, to bring it here? Then we really need a plan B for survival.
Asteroid mining is just about delivering the useful goods to the Earth. This will be completely safe. Nevertheless, you are right. An asteroid impact is inevitable.
Are you trying to scare us?
No.
But you really sound like a politician. You first invent some threat and then vote for me, give me some money, give me some power. I'm going to deliver you from this threat. Yeah, we've already heard this.
I'm not trying to scare you. It's all about time and probabilities. If you have enough time, even the tiniest probability would happen. Take, for example, the asteroid that killed the dinosaurs. It was with a diameter of 10 kilometers. Such a strike is a very rare thing. It happens every few tens of millions of years, but this would happen again, given that our solar system has 4 to 5 billion years of life in the future. And what can we tell about smaller objects? Right now, tonight, scientists from Italy, from Bulgaria, from all over the world, they are studying and they are tracking the sky for dangerous objects. But objects with a diameter of less than 100 meters are very hard to find because it's very expensive. That's why we need to dramatically increase the funding for space research. We have to build a planetary defense system for us.
You really try to scare us and you ask for money. But before continuing, let's make a short break. In our show, we have a part called Vox Populi. In this part, we talk with people on the streets. We ask about their opinion on the topics we are discussing here in our show. Their opinion is important for us, for we really believe in democracy. Please, let's have Vox Populi now.
For Vox Populi Talk Frankly, and today we are talking with people about the space research. you from?
Zagreb, Croatia. Zagreb.
What do you think about the funding space research?
It's kako se kaže, korisno. It's very useful for science. Yeah. So I probably would give money for that.
Do you have an interest about the transferring to Mars?
No. No.
You don't want to go out of space?
No.
Okay. Hi, where are you from?
I'm from Romania.
And would you like to fund space research in Romania?
Yeah, why not? It's something we need to do.
Why?
Because we need to discover other stuff. Maybe we can read something about this if you are responding. Maybe we can find something, let's say, on Mars. We can use it here.
And do you think to choose a scientist for a president?
Yeah, that'll be really awesome because they have a lot of knowledge. So for sure it will be something good for us, for the people.
Would you like to choose a scientist for a president?
A scientist for a president? Maybe there's a reason. I don't know whether the political leaders become their ideas from, and feel like maybe that is a solution for something.
But do you think that this person will be better than somebody with a political background, for example?
Maybe he will be better because he has the opinion and he has the knowing how to research and how to look after some details, and he's not on his career. He has a better background, I think.
Thank you very much.
Welcome.
As we all heard, people are not willing to go to Mars. In your book, however, you insist that we should colonize the planet right now. Why should we go there?
People also said they want a scientist for a president. In my book, I really do write that we should start from Mars. When we study Mars, we learn more about the history of the Earth. And why should we colonize Mars now? Because it's very close to the Earth, so it's our natural starting point. And you know, Danish, I admire them, those first men and women on Mars. They will write their names in history forever. Don't you want to be one of them?
No. I don't want to be one of them. I like the Earth, and I would like, first of all, to take care of it. In our show, we have a special part, the Minute of Danish. In each edition of the show, I take a minute to tell my own opinion about the issue we are discussing here. Tonight, in the Minute of Danish, I'll do something different. I'll do a very important and very surprising announcement. Let the Minute of Danish start now. I discussed it with my team. I got the approval of my wife because I'm still married. And I decided to announce my candidacy to become a president.
What? You're kidding!
I'm not kidding. I also wrote a book. Big book. Paradise, Here and Now. In this book, I explain my political ideas, the agenda I will implement once I become the president. You see, it's a big book, much bigger than yours.
But come on, size doesn't matter. It's only the size of the ideas that matters.
Namely, the size of the ideas. In my book, I put forward the idea that when I become the president, the first thing I will do is to turn the Earth into a paradise. With the highly developed technologies we already possess, we are able to transform the Earth into a real paradise, where there won't be hunger, there won't be thirst, and why not dream soon there won't be even death. Instead, because of our economical system based entirely on profit and consumption, we are about to destroy our planet Mother. And on top of it, today we are looking how to expand this model on other planets. Einstein once said, "You can't resolve a problem with the same way of thinking you used when you created that problem." That's why Professor Ivanov, going to other planets, plundering them, colonizing them, destroying them, is not a solution to the problems we are facing today on Earth. We will start the change not by changing the individuals, but by changing our culture, because the culture is the one that gives us values. Otherwise, we are going to a point of no return where the nature and not us is going to dictate the law. We will start the change of the culture by changing our educational system. Today, the educational system produces mainly workers for factories. Instead, I would like to see an educational system that develops the creativity of people, that develops our ability to perform independent critical thinking, so important for the proper functioning of a democratic society. Technologies like internet and social networks could also serve democracy. Instead, today they serve mainly to spread fake news and to gather our personal data that later is sold for profit. I'd like to be still alive in 2050, and instead of reaching the critical point of global warming, where the process became irreversible, to see 85% of our needs to be met by local small peer-to-peer producers, and only 15% of what we need to be produced by big international, multinational companies like our phones, computers, cars. And no one, except scientists, would ever remember what global warming meant in the past. It depends on us if you're going to turn the Earth into a hell or a heaven. Only the future will show. But the future is in our hands. The future is in our votes. If you want to see these ideas implemented in practice, vote for me. Vote for Nagy. Thank you. Professor, you insisted on several times that we should develop a plan B for the survival of our planet. It appears to me, though, that this is a plan only of the richest people, plan that they develop only for themselves when we destroy the Earth. But what is going to happen with the other 99% of the Earth's population?
Mr. Nagy, I'm surprised you are running for president, but I see you haven't understood my ideas. Space research is not about survival of the richest. It's about the survival of as many human beings as possible. Yes, you're right. Space is expensive. The first colony on Mars would be very expensive. The colonization of other planets will be at a huge cost. But as history has shown us, with scale, the price will go down. Once we regularly start to travel towards Mars, the price will go down steeply. That's why space research is not about survival of the richest. It's about having a chance of survival for our biological species.
Why should we go there only to repeat the same mistake like we did with the Earth? to plunder the planet, to destroy it. We should first develop a model for sustainable development here on Earth and then go to other planets. Otherwise, we're just going to repeat the same mistake.
No, we're not just gonna repeat the same mistake. Do you know why, Mr. Nagy?
Why, Mr. Ivanov?
Because, Mr. Nagy, when we go to space and when we take a look back at the Earth, we see no frontiers. We see no human-made limitations. And when we have this perspective, mind you, this is accessible only from space, we'll change our mindset. That's why when we go to space, we won't do the same mistakes again.
Those are only beautiful words of a politician that aim to please the audience, but that has nothing to do with the reality. Professor Ivanov, do you know which is the only flag today on Moon?
Which?
The American. We haven't resolved the problems we have here on Earth yet, and we're already transporting them to other planets. We divide them, we exploit them, we destroy them. But I would like first to speak about another idea of your book, the entropy hypothesis. You know, years ago I used to study geology, and I noticed that the ideas of my professor, and he was the theories of my professor, and he was the biggest geologist back then, were adapting to the new data that became available. With this hypothesis here, you're doing the same post factum theories. We are observing that we are destroying the Earth. There are no two opinions here. And with this hypothesis, you're making this look logical from the point of view of natural laws. Excuse me, this is not science, this is something cynical.
This is science, Mr. Nagy, because in science we have the scientific method and it can work both ways. Let me show you what I mean.
Cut it short, Professor Ivanov. We have only a couple of minutes left.
Okay, but let's say that you have an idea. Let's say that you think there are alien spaceships around the Earth. When you have the idea, you have to prove it. You have to find the proof. We pinpoint the space telescopes, we see no alien spaceships, and your ideas are disproved. But we may do the other way around. We may have the observation first, like we may observe that the moon is moving into the night sky, and then we can create the explanation, the theory of gravity, the theory of celestial mechanics. So you see, Mr. Nagy, in science it's completely okay to have the observation first and then the explanation. This is why science works, and this is why we should use the scientific method to make the political decisions also. How else can we be sure that the politicians are making the right choices for us, the citizens?
This is exactly one of the ideas in my book. Now I see that you already read it.
I haven't read your book. I have no intention of reading it. This is one of the ideas in my book.
Speaking about your book, you claim in it that the closest exoplanet to the Earth is Proxima B, right?
Yes.
How far is it?
Let me first say that Proxima Centauri is the closest star to Earth other than
Professor
the Sun.
Ivanov, we have not just a minute left of our show. How far is it?
Let me first say, Proxima Centauri is the closest star to Earth other than the Sun. Proxima Centauri
How far is it, Johnny?
4.2 light years away.
In kilometers.
40,000 billion kilometers.
40,000 billion kilometers. Given the current state of development of the human technologies, how much time approximately we would take us to get there?
Thousands of years, maybe tens of thousands.
Okay, stop. Everybody heard. Tens of thousands of years. According to the scientists that are using the very same scientific method you are so defending, only in 50 years here on Earth, we are going to reach the critical point of global warming. Beyond that, the process would become irreversible. Where then we should spend our money and our efforts on the problems that we have here today on Earth are for planets and stars somewhere far beyond in the space, tens of thousands of years ahead. Now, please, I'm asking your critical thinking. Where should we spend our money?
You are misleading the audience. We should start from Mars. A journey to Mars takes just 6 months. And once we have colonized Mars, the Moon, and maybe some other bodies in the solar system, then perhaps then we might have been able to acquire the technology needed to go to other stars, to other planets. But by colonizing the solar system, we would have done the most important thing. We will have a plan B for our survival.
You say perhaps. You use too many uncertainties, Professor Ivanov. But indeed, we have to finish our show. By tradition, it finishes with Ask the Audience. In this part of our show, we ask our audience about their opinion on some of the topics we are discussing in the studio. Tonight, with the editors of Talk Frankly, we decided, instead of asking our audience, to invite them to vote. Imagine that today is the biggest day, the day of the presidential elections. Close your eyes, think for a minute, and then vote, either for Professor Ivanov or for me, Danish Nagy.
Wait a moment, Mr. Nagy, wait a moment. I think it's a great idea to have the vote tonight at the Theatre of Wonders Festival. Let's raise the stakes. I propose you the following. If you win the vote of the audience, I will quit the race. But if I win, you quit the race.
You mean that if you win, I quit the race. But if I win, you quit the race.
Yes.
Deal?
Dear audience, you have a minute to think which candidate's ideas you would support. The minute is over. And the result is even. Thank you.
What should we do now?
I think we have to think of a joint campaign.
Wait, I first have to ask my wife.
Oh, ask her quickly, nice and sweet.
But of course, you get some small budget for your space researches.
Oh, no. Space research will always have the biggest budget, but sustainable development is also important. So maybe we should sit and talk about our joint plans.
Yeah.
Thanks
But
to the
come on,
audience.
everything is small with you. You got a small budget, okay?
No. A big budget, budget. Yeah.
Thank you. This was everything from us tonight. Please come back tomorrow for another part of Talk Frankly show. Thank you.
Hi guys, Gabriela Sanchez speaking. I also wrote the book, much bigger than yours.
Thank you. This is everything from us tonight.
Thank you. Thank you.